Oh, AP Statistics, we have made it to Unit 2. In Unit 1, we explored univariate data. This time, we're going to explore bivariate data. What's the difference, Ms. Griggs? Well, bi would mean two, so that is going to be two quantitative variables, and these variables should be very familiar to you. They are your standard x and y, and yes, I mean traditional x and y from the xy coordinate plane. That is what I am talking about. So this unit should be somewhat familiar to you. It is our only algebraically based unit, so you need to go on the assumption that, hey, you know what, some of this is going to be familiar to me, because it will be. So the first thing I want to talk about is the fact that the independent variable x, in statistics we call this the explanatory variable because it seeks to explain a response by y. So the dependent variable y we refer to as the response variable. So vocabulary is really important always, because what are we doing in statistics? We're not just doing math, we're communicating about the math. And that means we want to use our proper vocab, we want to talk about things like we know what's going on, you know, stuff like that. So there are times when you will be asked to decide which variable is which based on the context of the problem, so that's going to happen. You may also be asked to evaluate whether you think there's just an association or if it's really cause and effect, because it could be cause and effect. But I need to caution you on this. You are making this decision based on logic, and just because you see an association does not mean there is causation. So the goal of linear regression, the goal of Unit 2 is not to determine if we have a cause and effect relationship. All right, it could be a cause and effect relationship, but that's not our goal. So keep in mind, let's define what all of this could mean. So cause and effect relationship, what does that mean, Ms. Griggs? That means that the response you're seeing from y is in fact accounted for by x. For instance, use something common, like if you smoke too much, you could get lung cancer. Could one thing cause the other? Absolutely. If you stand around in high heels all day, are your feet gonna hurt? Yes, causal relationship. Look at that. Oh my gosh. If you study really hard, are you gonna do better than if you didn't study really hard? Yes, cause and effect, score. So a cause and effect relationship means that the variable x is directly acting on y and y is responding to it. All right, but sometimes you can see a relationship between x and y, and it could be caused by a lurking variable. And this is something that we're not accounting for. It's something that we don't care about. So what's an example, Ms. Griggs? Well, here's an example. Let's say you've got a scatter plot here. And this is roughly a linear relationship. See, they're all trending together in the positive direction. As x increases, y increases. These are ice cream sales. Yummy! These are water accidents. All right, accidents that happen in the water, injury and whatnot. Clearly, ice cream sales are causing water accidents to happen. I mean, everybody knows that, right? That's ridiculous, isn't it? Well, these things do in fact have a positive linear relationship, because guess what? As ice cream sales go up, water accidents do in fact go up. But it's not because of ice cream sales. What is causing these two things to have a relationship? It's called a lurking variable. What's the lurking variable, Ms. Griggs? The lurking variable is called the weather, kids. Because what two things go up when the weather gets hot? Well, more people buy ice cream and more people are out on the water. So there you go. So what does this look like? Well, it's called a common response situation, because ice cream and water are both going up. They are responding in common, but it is because of the lurking variable. So that is what you're seeing happen. So in other words, x, you have your variable x and you have your variable y, and they're both changing, but it's not because of each other. It's not because of x and y. It's because of something else. All right. So z, this other variable out here is acting on y, and it's acting on x to make it look like they're doing something, but they're not. All right, so then we also have a situation called a relationship that can become confounded. What does that look like? Well, with this one, it's something that gets tangled up with a third variable. Again, now x and y, okay, y is being acted upon by x, so they've got a relationship, an association, but z is also acting on y. So how do we know what y is responding to? We don't. Okay, a good example. Let's say I decide to, I don't know, start walking 3 miles a day. All right, so let's say I start walking 3 miles a day. Just to, develop some endurance, which you'd have to walk a lot longer than that to develop some endurance, but that's beside the point. So I start walking 3 miles a day. Well, I also decide to cut out sugar in my diet. All right, like processed sugar. Okay, so let's say I do this for 2 months. At the end of 2 months, I've lost 12 pounds. So why? All right, my response is my weight. Yes, it has decreased, but why is it? Is it because of the walking or is it because of the sugar? Well, it could be both. Well, they're both acting on my weight, so I don't know which one is causing it. It's confounded. So I can't really set up, hey, this is causing my weight loss. You can't do that. It's one of those, but I don't know. It could be both of them, could just be one. It's confounded. It gets all muddled up and you can't figure it out. So hopefully your intro to linear regression kind of gives you an idea of where we're headed. We'll get into more detail in the next video. Yay!